So after plane mirror, let's move on to the next topic, that is reflection from spherical mirror. So we'll now discuss the second topic of geometric optics, that is reflection from spherical mirror or spherical surfaces. Now, when I talk of spherical mirror, you know that what I mean. You have already studied that before. We'll be talking about two types of mirror in general, that is concave mirror and convex mirror. A concave mirror is basically when the mirror, suppose this is a spherical, this is some spherical body whose inner side is hollow, which hollow from inside, and I cut a mirror from here. So now I have a mirror like this. I have a mirror like this. A concave mirror is the one in which the outer side is polished. So this side is polished, that means it's a concave mirror. And a convex mirror is that in which the inner side of the spherical surface is polished. So this is a convex mirror. So in concave mirror, light will be striking like this, but in convex mirror the light will strike from outside. Okay, so these are the two types of mirror. Now let me define a few terms which you already know. That is, let's say I have this mirror. This is my mirror, polished from outside. That means it's a concave mirror. Okay, now there are some terms which I hope you know. What is the center of curvature of this mirror? Or what do you mean by center of curvature? Center of curvature is basically what? This sphere or this mirror basically has been taken from a bigger sphere. Okay, and let's say that the sphere from which this mirror has been taken, this is the center of that sphere. So this center of that sphere of which this mirror is a part is known as the center of curvature. Now again, associated with center of curvature we have radius of curvature. What is radius of curvature? Radius of curvature is basically this radius. Then we have something called pole. Pole is basically nothing but this is the spherical surface. Its center is known as the pole. This is the pole. Then we have the principal axis. Principal axis is nothing but this axis PC. PC is the principal axis in this case. Now there is something called aperture of the mirror. What is aperture? Let's say this mirror is AB. So this AB is known as the aperture of the mirror. Okay. Okay. So I have discussed center of curvature, radius of curvature, pole, principal axis, aperture. Did I miss anything? Yes, I missed what is focus. What happens is, if you have rays striking this concave mirror parallelly, then the rays converge after reflection at a point. Okay, so this point at which the rays converge, or the parallel rays incident to the concave mirror converge, is known as the focus. In case of a convex mirror, rays coming parallel to the convex mirror actually diverge. So if this is a ray, this will diverge. This is a ray, this is again diverge. This is a ray, it will strike back. This is the ray, diverge. It will also diverge. So the rays in a convex mirror actually diverge. So when you extend the reflected rays, they appear to meet at a point which is the focus in case of convex mirror. So basically what is focus? In case of concave mirror, the rays coming parallel to the concave mirror converge at a point known as the focus. In case of convex mirror, the rays coming parallel to the convex mirror appear to converge when extended, and that point at which it appears to converge is known as the focus. Okay, so these are the things which you have already studied before. Now I have a question for you. Let's say in this context, let's say I have a sphere. Don't go by the design, but let's say I have a sphere. Okay, now you know that the mirror formula states that 1 by u plus 1 by v is equal to 1 by f. Okay, this also you have studied in class 10. This is known as the spherical mirrors formula. Okay, so my question to you is, I have given you a sphere of radius r. Okay, now I am asking you to cut a spherical mirror out of this such that whatever you have studied in class 10 or before is valid. That means I am asking you to cut a sphere from this part, such that I can apply the mirrors formula. I can apply the whatever we have studied, we can apply here. So can you, like, you know, define, or can you cut a sphere out of this like that? Take 10 seconds and just answer if you can do that. Okay, so if I go by what we used to do before, I used to take a sphere like this. So you may tell me that I'll cut a sphere like this big, but is this true? No, this is not true. When we talk of spherical mirrors, or when we talk of the mirrors formula, basically what we do is we cut a small portion out of this big sphere, very small portion. That means actually when we are talking about this mirror with aperture, let's say AB, this is the aperture, actually AB is very small, it's very small. We draw it big, but actually it's very small. So actually we cut a very small portion like this from here. What is the reason? The reason is our mirrors formula is basically based on the assumption that, so this again I have drawn very big, but actually it's very small portion of this whole sphere. Okay, our mirrors formula is based on the assumption that the rays coming, or the rays striking the mirror, are very close to the principal axis. So the rays actually are very close to the principal axis. Okay, whatever rays strikes the mirror are very close to the principal axis. That means those rays are known as paraxial rays. It's parallel to the axis and it's very close to the axis. Why do I say parallel to the axis? Because in the derivation of the mirror formula, we have assumed a very important thing, that the sine theta, that the angle at which the rays strike the mirror is approximately equal to theta, and this assumption is valid only when theta is very small. So theta is very small, that means what? This theta is very small. If a ray strikes, this theta is very small, that means the rays are almost parallel to the principal axis. So our assumption is based on this fact. So since our assumption is based on this fact, we only can consider paraxial rays. Okay, and paraxial rays means rays parallel to, almost parallel, not exactly parallel to principal axis and close to principal axis. Okay, and because we have to assume this, we have to take this, so that's why we have to take only a small portion of the mirror, such that we don't have a whole set of rays striking the mirror. Okay, so this is something I hope you don't know now. You might not have been taught before, but I hope now you get what I meant when I talked about paraxial rays.